This webinar will be recorded, and if there will be 4 speeches, and if you have any question, please post it in the chat, and the speaker will answer after each speech. My name is Maria Teresa Natale. I am Senior Manager at the Michael Culture Association, and I am also the coordinator of the Museu Aggregator, which is one of the trusted Europeana aggregator. Just a few words about Michael Culture, which is a trans-domain European network in the sector of digital cultural content. It brings together a network of diversity of communities from cultural institutions, research bodies, Ministry of Cultures, private and public organizations from all over Europe. We are one of the co-founders of the Europeana initiative and a major actor at the European level in relation with the diversity of communities from the cultural and heritage fields to the European policy level. We deal with the several activities. We support the digital transformation of cultural and heritage communities. We manage, as I said, Museu, the European aggregator for European Museum in the data space for cultural heritage. We develop the use of culture and digital cultural heritage as a tool for innovation and societal issues. We perform research and professional training and capacity building on the related subjects, and we advocate for the place of culture and digital cultural heritage in European policies and programs. Today we are organizing this webinar within the data space initiative, and we choose this topic of enrichment because it is something where the Museu aggregator has always been involved very much. As I told you, we are working for museum, and very often we are also doing very artisanal work in aggregation, but we will see that there are several techniques to enrich metadata with processes and experiences which use automatic enrichment, artificial intelligence, and crowdsourcing. We are also involved in this project, but today we have selected 4 speeches. The first speech from Maša Škrinjar of Europeana, who will give us an introduction, and the 3 other speakers, which will explain us different technique of enrichment with technological tools. So the first speaker is Maša. Maša has a degree in art history and sociology of culture. She worked for various organizations on digitization and making collection accessible online. Her origin is Slovenian, but since some years she is living in the Netherlands, in Den Haag, where in Europeana is the data ingestion specialist. She is one she's specialized in the enrichment topics, so she will give a first introduction. So the floor is to you, Maša.
Okay, thank you very much for this introduction, and welcome everybody. So today the key topic of my speech is going to be the Europeana enrichment process. I work for Data Partner Services team at Europeana, which means that most of my day-to-day work involves in helping different organizations publishing their data in Europeana. Europeana is a digital library, or a portal, if you will, where we publish digital cultural heritage objects from different memory institutions. We work, for example, with archives, museums, galleries, and so on. All these organizations come from very different countries across Europe. They come from more than 40 countries, I think, and they're all providing metadata about these objects in different languages. So this is, for example, one of the challenges we're faced with. So we need to make sure that we can support our users in their multilingual search and browsing activities. And one way of doing this for us is to enrich metadata. It's an automatic process, but maybe first if we can see the presentation, please, and I will just quickly describe the first slide, because I think this is very important to understand that Europeana is not working with these memory institutions alone. So we are collaborating with organizations we call aggregators. So Museo is one of those aggregators. Some of them are domain specific, so they specialize in specific domain. For example, we also have a fashion aggregator that's aggregating all the cultural heritage on the topic of fashion. And the aggregators also have special technical knowledge. So they will advise the memory institutions about remapping data to Europeana data model that we use. They will advise on protocols for sharing metadata, for example. They will also promote different standards and frameworks that we have at Europeana. Yeah, so if we can just move to slide 2, please. Thank you. Not only that aggregators are providing all this advice, they are also the ones, in some cases at least, that they add some improvements to the metadata coming from these memory institutions. And then they pass this metadata on to Europeana, where we also apply specific processes and procedures before we publish this data. And one of those processes is automatic semantic enrichment. And we can move to the next slide, please. What I mean when I say semantic enrichment is an augmentation process of adding entities to the metadata that comes to us. So more specifically, Europeana has Europeana Entity Collection, which is a kind of knowledge graph. It contains entity about places, concepts, agents, organizations, and all these entities contain the information that's coming from controlled vocabularies. So some of the vocabularies that we work with are, for example, the Getty vocabularies. We also have some domain-specific vocabularies, for example, one from the fashion aggregator. And we are also relying on Wikidata quite a lot. So this enrichment process consists of 3 phases. The first phase is when we analyze the metadata coming into Europeana, and then we try to find the appropriate targets for this source metadata to be linked to. And on the slide in front of you, on the left side, you will see a part of the record. It's an XML record that comes to Europeana. You can see that it contains information, for example, about the contributor of this specific digital object, also the date when it was created, its title, and so on. So the record contains more information than just this. This is just one part so that I can show you how this enrichment works. And then on the right side, there's a idiom agent contextual class, but this is actually represents the Europeana entity for Picasso. And you can see that within this entity, we have labels in different languages, but we also have other information. So sometimes we're going to have a short bio. In this case, we have a note that tells us who Picasso is. We're also going to have core reference links. So these are the links to Picasso's entity in other vocabularies. So in this case, Wikidata, Wayaf, and so on. So when we move on to the second step, which is the matching, we will then look at specific fields in the source metadata record, and we're gonna match that to the fields within specific entity. We have matching rules which define how this match is obtained. I'm not going to go into too many details about this, but very briefly, we can, for example, match textual references. So in this case, we're going to match Picasso, so Pablo Picasso's label, to Pablo Picasso's label in the Europeana entity, but we could also do the matching based on the URIs. For example, if there would be a URI in the source data, we could then match based on the core references. So the core references are mapped to the same as metadata field in the Europeana entity. We will take into account the language tags. So we will never match something that has a language tag English to something in the entity that has a different language tag. We are quite conservative, I would say. If we find more than one match, we will not enrich. Then we have different rules. So for example, we will look at the specific fields. In this case, we look at the contributor, and we will only be finding matches with entities for agents. So we would never match a contributor with Europeana entity for a place, for example. But then there are other fields in the source data that are meant to be capturing the spatial information. And for those fields, we will be trying to find a match with the entity for a place. And then if we move to the next slide, we can see the final result. So the actual augmentation of the data. We will add the link to the Europeana entity to the record. And we will also add a contextual class. So the entity with all its properties, all the metadata that's within the entity, so all the labels and other information. And what's also important to note about this process is that we use the proxy mechanism, which basically means that we will move the metadata to different proxies. So we have provider's proxy. So this is the part in pink. And the provider's proxy is going to contain the original metadata coming from the memory institution. Then we have the Europeana proxy. This is where you're going to find the link to this entity that we enriched with, but you can also find here the results of other processes that Europeana does. For example, we do the date normalization, we do some other quality enhancements procedures. Very soon we're going to start adding translations. So this would all be on the Europeana's proxy. And the main purpose of having these different proxies is that it's easy for users to distinguish between the data that was provided by the memory institution and the data that was added later on during the ingestion process. I mean, this could be, for example, very important for someone who has a very specific reuse scenario. And for example, they decide, okay, we can only rely on the metadata coming from the memory institutions. We don't want anything to do with all the enrichments added later on. And it would be possible for them to see what was exactly provided by the memory institution. And then the part in green is this EDM agent contextual class. So every Europeana entity is an instance of a contextual class in EDM, so Europeana data model. So we have agent, place, organization, concept, and time contextual classes. In this case, as I said, Picasso is a person, EDM agent contextual class was added. And this is where you find all the additional information that's coming from those controlled vocabularies. So you have labels in different languages. You also, for example, have the dates of birth and death, and then you have the core reference links and so on. So what does that all mean for the user experience? If we move on to the next slide, you see the screenshot from the Europeana portal. And in this case, you can see the entity page for Picasso's entity. So every Europeana entity will have its own page in the portal. And usually we have a very short note about this person. Maybe we're gonna add some images later on. But what's important is that this page contains all the records that were enriched with Picasso's entity. And why are we doing all this? If we move to the next slide, please. So we're basically, by enriching the source metadata with entities, we're basically creating new links between objects. So if a user goes to the Picasso's entity page in the portal, it's going to be possible for him to explore all the other works by Picasso, and vice versa. If he's only zooming in on one record, he's only interested in one painting by Picasso, he can then still move on and see all the other works by him. Of course, this also improves findability, so we're actually adding a lot of additional information to the records. So we've seen, for example, that we now have the search and death dates, we now have labels in all different languages, and these are all index data, so they are searchable. And of course, because we have labels in all these different languages, this also improves the multilingual search. So for example, someone goes to Europeana, they type in keyword book, so an English word. But what they will retrieve are actually also, for example, records that only have French metadata. But if one of those records was enriched with Europeana entity for the book, then we will add English label, the book, which means that this record will also come up as one of the search results. So yeah, improved multilinguality because of all these labels in different languages. And of course, we are adding new context to the objects. And if we move to the last slide, please. So basically, this is the enrichment as it's done by Europeana, but this is not the only type of enrichment you will find if you browse Europeana. Because as was already explained in the beginning, we work with aggregators, and they are usually also the ones adding different types of enrichments. So even when we talk about metadata enrichments alone, they are very diverse. So some will be automatically generated by different tools, and you're going to hear about those tools later on. But some are also created by people, or for example, created within crowdsourcing campaigns, so with the help of citizen science. And in addition to metadata enrichments, we also have other types of enrichments. So there's a lot of emphasis at the moment on providing subtitles for videos, for example, or transcribing the written documents. And because there are so many projects focusing on this at the moment, we started questioning whether all the enrichment activities are really aligned with our long-term goals. And to make sure that they are, we are currently working on the Europeana enrichment policy, which is a document that will outline some of the main principles regarding enrichments, and this will then be distributed in our network. And we are trying to look at the enrichment from various different aspects. So first aspect, for example, is how you provide the enrichments to Europeana, whether this is as part of Europeana data model or perhaps via API. Then we would also like to look at the data quality aspect, because the aim of enrichments, we feel, should always be to improve the quality of the data. So to improve the quality of the data compared to the data as it was when it was produced by the memory institution. But of course, the question here is, how do you define the quality and how can you measure quality? Then we are looking at some copyright questions around enrichments. For example, do certain types of enrichments attract their own copyright protection? How would we license those enrichments? Because currently the Europeana's policy is that all metadata is under CC0 license. Then we also have questions, for example, would contributors of enrichments like to be attributed by name? And finally, we are also looking at the display. So how do we make sure that users can really make the most out of enrichments? How can we make sure they are reusable and that are useful for them for their needs in education, research, and so on? And of course, we would also like to look at the accessibility topic. So can we make sure that users with different needs can also use Europeana and can better use Europeana because of these added enrichments? So as I said, this is something we are currently working on, and the first version of the document will be ready by the end of the summer. We also had some consultations already. We circulated a survey with questions around some of the topics we would like to cover in this policy, but there will be more dialogue about this after the first version is published. So that's it from me. Thank you very much. And if you have any questions, I haven't checked the chat.
Okay.
But yeah.
Thank you very much, Maša. It was very interesting, and it is also interesting to know that this document will arrive very soon, because for us that we are aggregators, enrichment is always a very big issue, because it is connected to the tiers, to the quality of the metadata, and we always need to achieve good quality. So it is really very important for our work, and also for the work of the institutions. Now I see that there is a question. Bert Magnus of Mimo, he said, wait, I go again to the chat. He said, do the enriched metadata go back to the provided institution? If so, how is that done?
Yes, this is a very good question, and it's also something that's in our focus at the moment. So the short answer is no, or at least not in majority of the cases. You've seen the diagram on the first slide where we had the memory institutions, aggregators, and then Europeana at the top. I would say, sadly, this is the situation where we are at the moment. So all these enriched data ends up in Europeana, but there is no final circle. Those enrichments are not going back to the institutions that actually produced the data in the first place. This is something that's very desirable among CHIs, among memory institutions. It's also something that would probably save them a lot of time cataloging and adding additions later on. But of course, you can understand that it's quite a big challenge, because, for example, if you look at the museum or even any other type of memory institution, they're using very different management systems. So we would basically have to speak to all these providers of these systems to see what are the possibilities of importing this data, whether this is, I don't know, something as simple as Excel spreadsheet or something else. The reality of the sector is that only very few and only the richest institutions are currently having public API. So probably the easiest way to do this would be using the APIs, but it's just not a possibility for the majority of the sector. So this requirement is very much something we have in mind, and we would like to close the loop, but this process is not in place yet.
Okay, I have another question from Maddalena. I don't understand why doing a query, for example, with the word lemon, the results not always show objects containing the same word in other languages.
So you can only search for the metadata that's there. So for example, you can have a record that is about a lemon, but if in the metadata lemon is not mentioned in English, if no one recorded type lemon, then you won't be able to retrieve this record. But as I said in the beginning, because we are working with so many institutions with different language backgrounds, usually we have, usually when cataloging the objects, the curators will gonna catalog them in their native language. Only very few memory institutions are actually investing in translations. So, for example, if you have a French record about a lemon, if we didn't enrich this with the entity for lemon and add the English label for lemon, you wouldn't be able to find this.
Yeah, but if it is enriched with Wikidata, then you should find it, because this is in a dozen of languages. So this is something that we as a museum are pressing on Wikidata, because we are working about on capacity building on Wikidata. We find it very useful for the enrichment. Okay, thank you so much, Maša. I think your presentation was very useful for all of us. And the next speaker will be Eirini Kaldeli, which is a senior researcher at the Artificial Intelligence and Learning System Laboratory at the National Technical University of Athens. Her work focuses on the development of methods and tools that make use of cutting-edge digital technologies for data management, enrichment, crowdsourcing, and engagement in the field of cultural heritage. And she will give a presentation on the experience of automatic enrichment with text and colors in the Europeana Crafted project.
Thank you for the introduction, and thank you for inviting me today to give this presentation. And thank you, Maša, because your presentation was an excellent introduction also to my part, which covers, let's say, a different step of the overall workflow that you described. So the enrichments that take place before the application and the processing, the augmentation of the metadata performed by Europeana. Let me try to share my slides. And tell me whether it works. It should. Let's see.
Mm-hmm.
Do you see also do you see my screen?
Yes.
Yeah, we do.
Perfect.
Do you see all my screen or just
yes.
a window? Okay.
All your screen.
Oh, no. Okay, then it didn't work.
No,
sorry.
It's okay. It's okay. It's okay. It was okay. Okay, perfect. We see all your screen without the browser.
Okay, great. Thank you then. So I will describe an enrichment process that we follow.
Sorry. We just see also a window. Yes, this you have.
The window. Okay, let me. Sorry for this. Let me try then to do something else. 1 minute.
It is okay also if we see the side slides.
I don't know. It's give me 1 minute. I think I found it.
Okay.
Better now?
Yes, better.
Oh, okay. So in my presentation, I will try to describe a methodology for enrichment that we followed in the framework of the Crafted project, which aims to combine artificial intelligence tools with human validation for making the enrichment process more efficient at scale. So a few words about the Crafted project. So Crafted is a Europeana generic services project that has been running for almost 2 years. It is about to finish. It includes 14 partners, including museums, aggregators, technical partners, and Europeana. with the main objective to raise awareness about the value of crafts heritage via multiple activities. So via providing high quality crafts-related items to Europeana, as well as upgrading and improving the visibility of existing crafts heritage items on Europeana, via multiple editorial activities and user engagement initiatives. And also, as I already mentioned, the project takes crafts heritage as a case study to implement and test in practice a methodology for the efficient enrichment of cultural heritage metadata records. So availability of high quality metadata is very important, as already Maša stressed out, for a number of reasons. First of all, metadata is what supplements items' content with meaning and context and makes items searchable, more usable, more multilingual, and preservable. And in this respect, enriching metadata with links to establish vocabularies and knowledge bases, such as Wikidata and domain-specific vocabularies, is essential because it allows us to search items using a common terminology and allows Europeana users to gain a better understanding about what terms mean and gain a more contextual view of items. So to this end, state-of-the-art artificial intelligence tools can highly contribute to automating the enrichment process of metadata. However, the results produced by automated enrichment tools often suffer from low accuracy. And in order to scale up and improve the enrichment process, in the Crafted project, as I said, we aim to combine the power of AI tools with human intelligence for validating and fine-tuning the automatic enrichment process in order to derive more accurate, high-quality enrichments. So here we see the high-level architecture indicating the main components of the enrichment workflow that we are following in the Crafted project. So we are collecting new records via using the Mint data aggregation platform. And then after mapping the data to the EDM format, we apply a set of automatic enrichment tools. Those enrichment tools either analyze the content, so images, video, text, or they perform semantic analysis. Maša already explained what semantic analysis is. This refers to analyzing the textual metadata values in order to link with vocabularies and knowledge bases. Then the results of this the results of these tools in the form of automatic annotations are passed to humans for validation via the use of situation-appropriate validation tools. In the Crafted projects, we mainly used CrowdHeritage platform, an online platform developed by the National Technical University of Athens for conducting online crowdsourcing campaigns with cultural heritage metadata, as well as another tool called Sage that allows, again, users to validate the semantic links added to metadata. And this validation process informs the enrichment process. Filters are applied depending in each case, depending on the characteristics of the datasets and the end objectives. And in the end, the filtered annotations are embedded as in the EDM records and then published to Europeana as part of the overall records. So let me say a few more words about the kind of automatic enrichment tools that rely on content analysis, which have been applied in the context of the Crafted project. Those tools are provided by partner Datable and usually rely on computer vision components, either locally deployed or offered as services that have proven to give good results. The types of analysis that these tools perform include color detection. So they identify the dominant, the most important colors in an image, and actually on certain objects of interest depicted in an image. So, for example, after removing the background, whose colors may usually are not relevant, they perform object detection. So they can add annotations that correspond to labels that describe certain objects of importance in an image. They perform optical character recognition, both on images and videos, and speech to text in the case of videos. Then we also, as already mentioned, we apply a tool called SAGE, Semantic Annotations and Generation of Enrichments tool, for semantic analysis of textual metadata. So we analyze metadata values and link certain strings to URIs from controlled terminologies, Wikidata, domain-specific vocabularies, and so on. Different types of annotators can be applied depending on the use case at hand. So SAGE supports communication with the Wikidata Sparkle endpoint. It also allows us to upload and work with domain-specific vocabularies, apply different lemmatizers depending on the language of the metadata, and it also interacts with AI, named entity recognition, and disambiguation tools. So models trained on various corpora that are able, by taking into account the context of text, to extract named entities, so places, persons, organizations, and disambiguate them in order to find the right URI depending on the use case. For example, if the string Da Vinci exists in the textual field, the tool will try to disambiguate and understand whether this refers to the airport Da Vinci in Italy or to the Renaissance polymath Da Vinci. Here I tried to, I will try very briefly to describe the main steps of the methodology we're following in the Crafted project. So the first step is to study in depth the characteristics of the datasets, both in terms of content and in terms of the metadata. For example, to understand what is relevant to do, depending also on the objective, and what is feasible. For example, does it make sense to extract colors from images because we wish to support search by color? Do we wish to perform optical character recognition because images are photos with inscriptions, for example, and those inscriptions contain information that is missing from the metadata about the creator or places and so on. So we try to understand what also format the metadata values have, because often providers do not always put the expected values under the respective metadata fields. So, for example, we have found cases where providers indicate organizations under DC Spatial, and so on. And then, of course, we map the metadata into EDM. And based on this requirement analysis that we have performed, depending on the characteristics of the data as well as of the objective of the enrichment, we apply a right combination of annotation tools and automatic annotation tools and steps. And I have given some examples of types of AI tools that we have applied in the context of the Crafted project. So the third step is human validation. So humans, via the use of appropriate tools, are solicited to review and validate a carefully selected sample of the automatic annotations. Because we are talking about annotations at scale, of course, it's not feasible to ask from humans to look at the annotations, to all added annotations. So selecting a carefully balanced sample is key in this process. And I will come back later in my presentations to this, to the selection of the appropriate sample. And based on the feedback that was provided by humans, we compute metrics that are relevant to the situation. Again, I will give some examples later on. And based on those metrics, we established appropriate thresholds for filtering. For example, we may decide to keep the results of certain annotations while prune the results of other annotators. And then also the human feedbacks allows us to gain insights about the automatic enrichment tools and their results, and probably fine-tune and revise the automatic annotation workflow that we followed. For example, to apply more appropriate string matching rules, or to apply more steps, for example, to first perform object detection and then color detection on certain objects, and so on. And the last step, of course, is to embed the annotations as enrichments in the idiom records and publish to Europeana. So let me give an example. Let's assume that we have a data set that consists of photographs of items, and those photographs also have labels on them that describe the item with information about creators, places, and a description of the displayed item itself. And that the metadata accompanying this culture heritage item is rather poor. Then we may decide that it is relevant to apply OCR on the image. So we apply established tools. So for example, Google Vision's text detection service, as well as a service for language detection, then on the resulting OCR. And then we decide to pass the output of the OCR, the detected text, to the SAGE tool in order to semantically analyze the text and extract useful information, entities that can be linked with Wikidata. Then we perform some preliminary validation first on how well the text detection performed, as well as on some in-depth validation and preliminary validation, also in-depth validation of the semantic enrichments that were identified by the SAGE tool. Then we statistically analyze the data by using situation-appropriate metrics. So in this case, a relevant metric could be word index error rate for the detected text. So how many words were identified correctly from the image, and how many were missed or incorrectly identified. And for the semantic analysis, usually we use precision as a metric, which indicates how many of the matches that the tool found were correct among all the matches that the tool found. And then we may fine-tune step 2, for example, adapt the language detection tool, decide to use a more domain-specific vocabulary instead of generic NERD, so named entity recognition and disambiguation, and so on. Adjust our string matching rules, our lemmatization process, certain steps of the automatic annotation workflow. And then filtering is applied and publication to Europeana. So this slide depicts how, shows how the validation on Sage looks like. What human validators see on the Sage tool. So on the left side, they see the metadata values. In this case, I think this is DC description. And the strings matched by the tools with some URI are marked in red. And for each string on the right, they can see the URI that was matched with the respective string. In the middle, also users can see how many items are affected by this annotation, because the same string, the same values, it's very often that it is found in multiple items. And then validators can accept or reject the URI and even add their own matches. So human annotations add the URIs, match certain strings with correct URIs. Another validation tool that we used is CrowdHeritage, as I already mentioned. This is a tool that, while the Sage validation is mostly addressed to culture heritage experts, so people who are familiarized with EDM metadata and with the terminology used in their domain, CrowdHeritage is a platform that is addressed to broader audiences. So in the context of the Crafted project, it was used for validating colors. So this is a task that usually does not require a high specialization in a specific domain. So during the crowdsourcing campaigns, validators were asked to validate colors, vote or upvote or downvote colors detected by automated color detection algorithm that was applied. And actually, via some campaigns, we aimed to compare the results of different algorithms to see which algorithms performed better. Then the human validations results were analyzed. As I said, as I already mentioned, the selection of the sample is very important. The sample does not, it's not necessary that it is large, but it has to be very well balanced and to take into consideration multiple dimensions. So to make sure that it includes content with different characteristics, that it covers sufficient number and sufficient types of fields. Fields with longer textual values, fields with shorter textual values. It has to be make sure that also that annotations that have a higher impact, that refer to more items, are prioritized. Also, we have to make sure that both annotations with low confidence level. So if the automatic tool, in some cases, the automatic tools produce an automatic confidence score that indicates how confident the tool is about the annotation it produced. So we have to make sure that both annotations with high as well as annotations with low confidence levels are validated by humans. Then situation appropriate metrics are computed. I already gave some examples about this, and it's important to say that again, the annotation metrics are very dependent on the situation, and in some cases it makes sense to calculate them at the dataset level, in some cases at a more granular level, for example per field or per language. And then the filtering takes place. Usually, in most cases, we applied filtering based on the precision per field. So how accurate the annotations were on a field basis. And we only accepted annotations for which we found that the precision of the tool was above 70 or 80%. And pruning also took place with respect to rejected URIs. And in general, we also tried to apply other approaches, to adopt other approaches for filtering based, for example, on the correlation between the automatic confidence scores and human judgments. But I will not go into more technical details. Let me just give an overview of the results we got regarding color detection. So we conducted 3 crowdsourcing campaigns for color validation involving different types of CrowdHeritage images from different museums. 5,000 images were reviewed and validated by 185 contributors, students, citizens, cultural heritage professionals. What is important, an important conclusion is that the precision of the algorithm highly dependent on the color. So the algorithm, the color detection algorithm, performed very well for certain colors, while it performed less well with respect to other colors. So I've indicated here with orange color the colors for which the precision was not satisfactory enough. So those colors were pruned out before publication to Europeana. With respect to the semantic enrichment, some general conclusions that we can draw is that usually good quality domain-specific vocabularies led to very good results, high accuracy results, while generic NERD, named entity recognition and disambiguation, usually did not perform that well in long textual values, either because it extracted 2 generic entities, for example, linking the string human with an entity human on Wikidata is not very useful and it would be usually rejected by humans, or because of wrong disambiguation. For example, the name John Ellis, it can correspond to 10 different persons, and it's very difficult to really conclude with accuracy what the relevant person is in each case. Also, the analysis of shorter fields such as DC spatial, creator, and so on usually led to better results, and analyzing OCR outputs or DC descriptions, so long values, long text. And also we found out that the attitude of the validator also affects precision. So in some cases, data providers were very strict and wanting to include very specific terms. So they rejected terms despite the fact that they were correct because they did not consider them relevant to the objective they would like to serve, where other validators were more tolerant in the sense that they wanted more generic concepts to be included in the metadata. And also this process, the human validation process, allows us to fine-tune the semantic analysis in many ways. In total, we managed to enrich and publish to Europeana. Okay, the publication process is ongoing. About 127,000 items, with at least one automatic enrichment resulting from one of the tools that we applied. To conclude, regarding the potential of this approach of combining artificial intelligence with human intelligence for the enrichment of Europeana metadata, we think that this methodology has proved that it can scale up the enrichment of metadata in a cost-efficient way without the loss of accuracy. So the lesson we learned is that automatic tools are not mature enough yet to be trusted blindly, and human validation on a carefully selected sample is necessary in order to ensure high precision results. And also, finally, I would like to add that an important lesson that we learned is that there is no one-fit-all solution. It's very important to study the characteristics of the data set and the objective and adapt the workflow, the automatic AI tool set that is relevant in each case, depending on this. So thank you. I don't know whether there are any questions.
I wanted to add thank you, first of all, Eirini, while we are waiting to know if there are some questions. I wanted just to say that probably the crafted topic was quite a big challenge for this project because, for example, we don't have very many domain-specific vocabularies. I mean, trusted vocabularies, because, for example, in Crafted, we have a lot of vocabularies made by companies, by sellers, and so that are not trusted, and anyway, they are not multilingual. Probably in other topic, probably in a project of archaeology, for example, the results would have been better because the AT is rich, is full of terms. There are a lot of translations, while for Crafted really there are not many vocabularies. This is my idea. I am not a technical person, but looking at your slides, I just wanted to make this reflection.
But I would like to add to what you said, that also Crafted contributed with a vocabulary describing Greek characteristics of Greek crafts heritage. And actually this also led to very good enrichment results, the use of this domain-specific vocabulary.
Yes, okay. There are no other questions. So I think we can go to the next speaker, which is Konstantinos Chatzitheodorou. Complicate to read. Konstantinos is an expert, is an authority in the fields of computational linguistics and deep machine learning because he demonstrates a high level of proficiencies and expertise in this area. He is head of machine learning at Pangeanic, where he leads the development and execution of the company's machine learning strategy, and among his responsibility there include designing and deploying machine learning model and algorithms. So now Konstantinos will give a speech about the experience of using artificial intelligence in the Europeana Translate project.
Thank you, Maria Teresa. Thanks everyone for attending this workshop. Welcome to my presentation with titled The Experience of Using AI in the Europeana project, Europeana Translate project. Before I start with my presentation, I would like to talk about the objectives of the project. The objectives were, first of all, to build machine translation engines in order to translate metadata, especially 25 million records from Europeana repository into English, from different languages into English, and sending them back to Europeana core service platform as enrichments. In addition, one of the objectives was to add 10 million of metadata records from Europeana to the ELRC share repository. And everything that we developed is open sourced, and it's very easy for the cultural heritage institutions, service provider, and anyone interested to download them and use them. What were the challenges during this time? One of the big challenges was that there were not machine translation tools that were trained on data with little overlap with current architectural metadata. For instance, e-translation, which is a European project, is translated mainly on legal and administrative texts. Then the metadata come usually in short phrases or single words, which is a bit tricky for machine translation to provide a high quality output. They use specific terminologies, which is also tricky during the translation. And it's not easy to interconnect with tools and platforms used by Caritas cultural organizations. Our contribution to this project was, as I mentioned earlier, to train 23 machine translation engines from official EU languages into English. We trained these engines using generic data, and we enhanced them using data from Europeana. And we also used some resources that we collected during these projects. I'll show you later what was our methodology. The translations were evaluated by linguists, by humans, and by cultural heritage experts. And we achieved high quality scores for the majority of the languages. And I'll show you later how we use AI in order to make this decision, and how we use the human feedback in order to make the decision if the machine translation of the 25 million records is high quality or not. The methodology we used and the AI techniques we used during this project. Let's go to the training process. The first step was to prepare the data. After the data is prepared, we train the models, we package the models so that we will be able to validate them, and then we deployed. And now that the models are deployed, we monitor them in order to make sure that they work, and organizations and Europeana can anytime translate using these models. What are the conditions for training the models? The first and the important step is to collect the data. So in order to train, in order to create a machine translation model, we should have sufficient parallel data. So source language text together with the corresponding translations in order to feed the systems and achieve high quality results. The quantity and the size of the dataset has, of course, an impact to the model performance. So the more data we have, the better the results are. However, we don't feed the systems with raw parallel data. We have to pre-process this data in order to remove the noise, to correct some errors, to normalize the data towards a better machine translation output. Regarding the training infrastructure, we should mention that it is a time-consuming process. We use AI algorithms in order and technologies in order to train them. We need computer power. We should have at least GPUs in our architecture in order to train, and a lot of memory, and maybe it lasts days on week. So a medium-sized model for Europeana was trained in 1 week. Of course, it's not an easy process, because depending on the language, depending on the training data, the data set size, we have to find the high parameter tuning. So we have to run different tests, different experiments in order to select the fine-tuning parameters. meaning the learning rate, batch size, network architecture, etc. And during this process, it's important to evaluate, to measure the quality, so that we will see if there is room for more training in order to achieve a better result, or to stop at this checkpoint because we reached the maximum with the current architecture we designed and the data sets we have. Data collection and preparation. As I told you, it's very important to collect the data, to create a very big data set and prepare it so that it will fit the system. For this project, we used generic data, mostly for European Commission and from Wikipedia, as well as some domain-specific data provided by Europeana and glossaries related to this terminology. We should highlight that Europeana didn't have data available for all languages that were in scope. So for a few languages, or for the languages that we didn't have enough data, we applied AI algorithms in order to crawl the web and create such data sets. Data collection and preparation, dataset cleansing. What are the algorithms performed in order to clean our data? We followed the Pangeanic's AI preprocesses. We have designed standard preprocesses for the data, and these are language dependent. So for each language, we apply different rules because, as we understand, not all languages are the same, have the same structure. So we identified if the source was the same and target. We were removing these segments from the dataset. We were checking if there is a mistranslation. For instance, if the source segment was long but not the target segment, and the language was not similar to German, for instance, we were removing the segment. Then we segmented all segments, all sentences that were not segmented, meaning that sometimes we had a big paragraph that was split into sentences because the systems, the machine translation engines understand better or perform better on a sentence level. We detected, we applied language detection in order to make sure that we will not cause problems by adding in an Italian corpus, for instance, other languages like Greek or Latvian. We removed inconsistent targets, so cases where the same source segment had different translations. We normalized the numbers as well as the punctuation. For instance, we normalized the punctuation for French, the curved or the normal quotation. And then this data was split into train a data set in order to perform the fine-tuning. Regarding our architecture and the training methodology, we used state-of-the-art transformer architecture in order to ensure high quality of output. We trained bilingual model. We had some experiments in order to train multilingual models, so to have one single multilingual model, but we saw that it performed better if the data, the engines are bilingual. And then we ran some experiments in order to find the best quality. So we trained with synthetic data. So we used monolingual data, and we generated their translations, the synthetic translations, in order to train the system. We saw some improvements, but results were not very good. And then we enhanced this data with glossaries and terminology from this domain. And we concluded to a hybrid solution, so a solution that contains authentic data, so parallel data from humans, plus data synthetic with glossaries, etc. As I told you earlier, it's an important step during the training process is the automatic the evaluation. And this evaluation, in this case, was automatic. So we applied some standard metrics, some state-of-the-art, in order to evaluate the quality and see if our engines perform well. In these slides, I present the metrics. We used CHRF, which estimates the quality based on the overlap of n-grams between source and reference. Translation error rate, which is more or less the same. Blue, bilingual evaluation understanding, and COMET. In addition to this, we compared our results with e-translation outputs and Google Translate output, as well as
Sorry, one moment. Juliet, Igor should silence himself, or Juliet, you can silence him. Please go on.
Okay.
Okay, so yes, in addition to the automated metrics, we compared our results with e-translation and Google Translate, as well as engines created by Pangeanic so far, so that we will see if where we are in terms of quality. And to do so, we created a test set of 1,000 segments for languages that had enough amount of data, and for languages with a few or a fewer segments, we used less segments or synthetic data. In addition to this, we performed a campaign for human evaluation, and we used two different platforms. So we used MTET platform, which is developed by Pangeanic, and this was used by linguists, expert in these domains. And we also used evaluation or the platform, the CrowdHeritage platform from NTUA, from National Technical University of Athens. And this evaluation performed by cultural heritage experts. Why we did this? We did this in order to compare the results with humans and with the automated metrics, and try to find a threshold and correlate this with the automated metrics. I'll show you in the next slide. I'll show you another methodology that we used, and it uses deep learning in order to estimate the quality of machine translation. So let's go back to the human evaluation. A human evaluation performed by Pangeanic and by University of Athens, and the aim was to have some feedback for the translation. Based on this feedback, we created an algorithm in order to estimate the quality of human translation. So every time someone, a cultural heritage institution, or anyone translates using Europeana's machine translation services, they receive a confidence score, quality estimation score, and this estimation score correlates with the human evaluation, with the human scores that we performed. what is this algorithm about? It calculates the error rate, word error rate, character error rate, and F1 score. I think it's technical, so maybe we don't need to discuss, but it takes into consideration this one, and takes also into consideration the human evaluation, because the models were trained based on the humans, based on the scores that we received of humans, and output a result which is different per language. So it correlates, has a different weight per language. And all this AI is applied to Europeana's framework. So Europeana created an API, and this API, this API is integrated with the engine. So when users translate, we apply language detection, then we machine translate with the engine, then we estimate the quality, we calculate the quality based on the human output, and then if it's more the threshold we have, in this case I have 75% of threshold, we publish this this translation. Otherwise we don't publish it, and we should find another technique in order to improve the results. But so far results are good. So only a few segments over the millions that we translate have a bad quality, and yeah, maybe in the future we have to improve. We have to fine tune the engines so that the output will be improved. Thank you so much.
Okay, thank you, Konstantinos. There is a question for you.
Yes.
Peter was asking, can you give us some example which languages were those where the insufficient data set were replaced by artificial intelligence?
Mm-hmm. Yes, Croatian, Latvian, those two languages are languages with low resource, and I think that we didn't have data for Maltese, and I think that we don't have an engine for Maltese, so maybe in the future. But yeah, Croatian, Latvian are the languages that we don't have data. These are the language I know. If I have 2 minutes, maybe I can find all this information, or maybe Eirini can help us. She knows the project.
Yeah, I think these are the ones: Croatian, Latvian, and also Irish, I think.
Yes.
And I remember that there was no Maltese data at all.
Yes.
Yes, and then I have a question on one of your first slides. You were speaking about an ELRC share repository. What is it exactly?
Let me check. So the first slides.
One of the first. You said that there were 10 million.
Yes, 10 million. Yes.
Yes, adding 10 million metadata from Europeana to.
Yes. They will go to the ELRC share repository. I think it's a public repository, and yeah, it's
Okay.
It's a data repository. So this data will be available to anyone interested.
It's okay. Thank you, Konstantinos.
Yes. It's a repository, and we have there the Dockers for the engine. So anyone who is interested can download the Dockers and use them locally.
Okay. Thank you very much.
Thank you.
So now we will go to the last presentation of Pier Giacomo Sola, a colleague of mine in MCA, and Pier Giacomo Sola, he too is a senior project manager, which really have a big expertise in the design, coordination, evaluation, and technical assistance of transnational project, and he has contributed to over 100 research projects and studies in culture and education. He will speak us of another project. This time it will be less technical, and he will speak about the experience of crowdsourcing in the CrowdSchool and CrowdHeritage project, where again we will see the use of the CrowdHeritage tool that was already quoted in the previous two presentations.
Thank you, Maria Teresa. I'm going to share my screen. I guess that you should
Yes.
see. Perfect. So, of course, being the last one and knowing that, I am benefiting, I'm taking benefit of the previous presentation, because I will not tell you what semantic enrichment is. Thank you, Maša. I will not explain how the CrowdHeritage platform works. Thank you, Eirini. I will not talk you about all the problem of linguistic adaptation. Thank you, Konstantinos. I will focus on CrowdSchool. CrowdSchool, at the very end, it started already in our mind when we were preparing the CrowdHeritage platform. We have been directly involved as Michael Calci in the work together with the National Technical University of Athens, the Minister of Culture in France. And because in the testing phase, when it was necessary to check if the semantic algorithms created by artificial intelligence were in the right way, we already contacted some students, some schools, in order to use their capacity, ability in running and using the computer for the piloting phase. And of course, we discovered that there was a lot of interest about this potential use of the collection of Europeana for educational purposes. So we started thinking about a way to reuse all this experience, not for one of the Connecting Europe Facilities projects that have been already presented, crafted, translated, and so on, but using, on the contrary, the Erasmus Plus education and training program in order to start our idea. And indeed, we presented the project that was started on the 1st of September 2020, and it's going to be completed at the end of August this year. So what is the training model that is at the basis of the CrowdSchool application? Well, first of all, we have to work with the schools. So the school teachers selected some themes of their interest in order to be compared with the objectives of the program of their school. Then we have, on the contrary, the work of the people that well know the Europeana collection in order to identify what are the digital collections that can better respond to the educational needs of the teachers and the schools that are connected. So together, the teachers and the cultural professional work together in order to define the terminology to be used for the specific themes, and also to select among the 60 and more millions of items present in Europeana what are the more relevant ones for the specific objectives of their scheme. And of course, this is also easy to be done thanks to the Europeana galleries that were created more or less in the same period when the project was started. Then the students started the semantic enrichment campaign in order to annotate the items according to the terminology list that have been selected by the teachers and by the cultural professional. And of course, the teacher revise the work that has been done by the student, but in order also to have a peer assessment of the work that has been done by each of them, also the other students can intervene in order to approve or disagree with the level of enrichment that's been done. In this way, we have a human level of quality that is created in this way. This is, let's say, the overall model. We added, in order to create the possibility of the schools to replicate the experience in the following years, also created a virtuous cycles in which the most effective student of the previous years played the role of mentors, of tutors of the students of the following years in order to show them how the mechanism is working and, of course, be able to replicate the system in a perpetual way without the intervention of external people that, of course, should not have the time once that the project is over. So, in the 3-year project, we spent the first year in order to improve, let's say, to adapt the CrowdHeritage platform in order to be coherent with the requests coming from the teachers that, of course, had different necessity, different needs with respect to the original scope of the CrowdHeritage. During the first year, also the collection and the educational teams have been selected, and we could start the first crowdsourcing campaign during the school year 2021-2022. After some revision, new sets of collection has been also selected in order to increase the opportunity for the new teams. And the second Pure Learning campaign was started at the beginning of October and has been just completed now with the end of school in May. And of course, we could also test the effectiveness of the tutoring scheme provided by the peer school fellows of the new students. Finally, we are finalizing the guidelines recommendation in order to give the possibility to any school or museum educators that are interested in replicate the models to do with their own scheme. And let's say what was excellent, and I'm not tired to thank once more the National Technical University of Athens, because now the platform has been really improved in order to be very, very effective and provide the opportunity really to every school to do it by itself without the need of an external support that can, of course, create a delay or have some challenges still to be solved. The partners of the project, we try to work, as I already mentioned, with both school and cultural professionals in 4 countries: in Spain, Associación de Dal e Moderato in Barcelona; in France, Michael Culture and the primary school of Joinville-les-Pons near Paris; in Italy with STEPS and the Artistic Lyceum, the School of Art in Bologna; in Poland with ISEMS, that is also one of the partners of Crafted, together with a school specialized in architecture in Yaroslavl in Poland. We also have the National Technical University of Athens and the European Fashion Heritage Association with the role of horizontal transversal support to all the different teams. So the partner school have identified the themes, and we have in France cities of landscape, Olympic spirit, because the students also were interested in knowing more about the Olympic Games, since Paris is hosting Olympic Games in 2024. In Spain, there was a lot of themes that were selected by the school: musical instrument, the architecture of Gaudi, food, and animal endangered species. In Italy, the School of Art selected themes arts and food in the centuries, and clothes and garments in the arts. And finally, in Poland, they focus on architecture and landscape and gardens. So the creation of terminology was quite important, as you can imagine. First of all, in order to avoid the use of free texts that could create synonyms hardly to be managed by the platform. Secondly, because we were working with 4 students, with 4 countries, with students that more or less could know English, but not Italian, Spanish, Polish, and French. So we use Wikidata in order to select items that were partly translated or whose translation was completed by the joint teams at the very beginning in the first school year, in order to create the schema that has been used by the teachers and the students. In such a way, all the students could use their mother language in order to increase, to annotate, to increase the number of metadata, but all the other schools could read the new metadata in their own languages, so facilitating also the cross-tagging and the approval or disagreement with the work that has been done by the other students. So how does it work? First of all, we have to work with the CrowdHeritage platform and select the language for the annotation. In the origins, there were only 5 languages, and then also the Greek has been added in order to increase the possibility. Several crowdsourcing campaigns were present, at least the 12 that has been created by the student, by the school for the CrowdSchool project, but also the other one created by eTranslate, by Craft, were available, of course, not for new annotation, but at least to check and to see and to have some more information about the contents of Europeana. After selecting the campaigns, the different campaigns were organized in different items. For instance, the collection concerned with food in the art was divided into the different centuries in order to facilitate also the selection and identification of the different items. Within each collection, several tens, sometimes also several hundred images were available, and in such a way the student could really start their semantic annotation. Semantic annotation was not only referred to the terminology list that has been created, but there was also the possibility to identify the geographic location of the item in order to increase also this kind of information. And finally, there was also the possibility to create a free text section that for sure is not possible to query on, but it was very useful to increase the educational purpose, because all the students were invited to select one or more of the paintings that were present in order to go in depth, make a research about the painters, about the people or the food or the clothes that were presented in the painting, and in such a way to increase their knowledge about the content of the collection. Of course, we tried also, since there were students and young people, to create a gamification process in order to increase also the competition. And for each activity that was done by the students, there was a score given to them in order to give, let's say, a label, a grant to the students that more actively have been working on the platform. And of course, there was a small present that has been given to the more brilliant student, but without having a direct effect on the collection itself. So, of course, all the work done by the student can be checked and corrected by the teachers in order to increase the quality of what has been done, because all the work has not been given back to Europeana. The Europeana Foundation, of course, is well aware about this project, but was not directly involved in the activity due to the lack of the staff. But in principle, all this information is ready to be transferred back to Europeana in order to provide the benefit of the work that has been done in these couple of years by the student of the 4 schools that has been involved. So, finally, we are at the end of my presentation. We are, as I was mentioned before, finalizing the recommendation and the guidelines how to use the platform. Of course, these include, first of all, a hands-on on the platform, just to explain how it works and how it's possible to connect and take benefit of the different devices. But then there is also the possibility to take note of the comments, suggestions, direct experience coming from the teachers that, of course, have been the guinea pigs in these couple of years, but are now in the front line in transferring the experience and providing good suggestions to their own colleagues all over Europe about the use of the platform. Many thanks for your attention, and I'm ready to answer any question if you have interest in this topic. Thank you very much.
Thank you, Pier Giacomo. I wanted to add something. First of all, that this project is really a very interesting project for reusing in some way the contents present in Europeana for educational purposes. Then I wanted to say that it was a challenge because the students were very different, from very little students to high-level students. So also the work on the vocabularies was different, of course, with the more detailed terms for the biggest one, and simple terms for the little one. And third, it is really a pity that we cannot transfer not the new description, but at least the metadata to Europeana, because in fact this enrichment has passed the 2 levels. The first one, the student level, and also the teacher level that has verified the work of the students. So in this case, I think is a double level of validation, and it would be nice that Europeana could profit of this work.
Yeah, if I may add one more benefit for the Europeana Foundation was concerned with the creation of galleries, because I mentioned that the gallery were created some years ago, more or less at the same time of the CrowdSchool project, and Maddalena is one of the persons that is working, has been one of the more active persons working in the creation of a gallery, and she's in direct contact with the people in the Europeana Foundation that are working on these themes. And of course, this is another good benefit that has been created, a good cooperation between Europeana and the educational world.
Okay, Pier Giacomo, then we have Lara that is asking, she is saying that she would like to deepen this study and she would like to know if you have written any articles about it.
Well, we have prepared some presentation, not article in scientific publication, but we presented the CrowdSchool project in some conferences. So perhaps there are a proceeding of a conference, but I can write my email address in the chat, so we can come in touch in the next days. Just so I will send you all the references that has been created until now on the project. So just to give you some more information to transfer how it works.
Okay, so I think that this webinar was very interesting with different level of technicalities, of course, but with the initial presentation of Maša, the two more technical presentation and the Erasmus Plus project at the end. But I think that it was very useful to understand something more about semantic enrichment. Of course, in the following day, we will publish the video of this webinar, and we will also make available the slides. I have already the slides of Maša and the slides of Pier Giacomo. I kindly ask Eirini and Konstantinos to provide me also their presentations. And I thank you very much, all the speakers, all the participants, of course, and I would also like to thank Juliette for her help in using the platform. I hope to see you soon in other events.